Okay, so today we are going to work on solving equations that have everyone's favorite fractions in them. So I'm going to show you guys two different methods. And the one we already know, but I just want to be clear that the same methods that work with whole numbers will work when we're trying to solve equations with fractions as well. So the first method is just kind of deal with the fractions as if they're just numbers, which of course they are. So if I have this equation here, right, and instead of 2/5 x minus 8 equals 12, it would just say 2x, right? So, if I had this equation here, let's write it out. If I just had this, right, at this point, all of us know that all I would have to do is add 8 to both sides, okay? Well, that doesn't change because of the fraction. I still add 8 to both sides. And let's see where I am. Okay, I've added 8 to both sides, and these cancel out. So that leaves me here. I know that 2/5 of x is equal to 12 plus 8, which is 20. Okay, now, in order to solve this from here, right, I have a dividing by 5, right? So look, if I had, 2x equals 20, I would just divide by 2. I'd do the inverse. Okay? Here I have 2/5, which is a times 2 and a divide by 5. So I'm going to multiply by 5. Okay, and let's see what happens. These are gone, and I'm left with 2x equals 20 times 5 gives me 100. And then all I need to do, of course, is divide both sides by 2, and I get my solution. Okay? So it works the same exact way. Just when you get to the fraction times x, you're going to multiply by 5, right? Because that's in the denominator. So to cancel out the denominator, you multiply by 5. And then you divide by 2 to cancel out the numerator. Now this one's a little trickier, right? But it works the same exact way. If these were whole numbers, right, we would be thinking, I want to get all my x's on the same side. So I'm going to go ahead and do that. So I'm taking away 1/3 x from both sides. Now this is where it gets a little tricky. I have 2/5 x take away 1/3. All right, so let's see. I need to subtract these fractions. I need a common denominator. I'll use 15. So 2/5 is 10/15. 1/3 is, I'm sorry, that's a mistake. 2/5, 5 times 3 is 15. 2 times 3 is 6. 3 times 5 is 15. 1 times 5 is 15. So when I subtract these, I'm going to be left here. I'm going to have 1/15 of x plus 4 equals, all right, these are gone, equals -6. Okay, so now I'm going to subtract 4. Okay, and I'm going to be very careful about negatives. So that leaves me here. I'm going to come over here to finish. These are gone. And I'm left with 1/15 of x is equal to -10. So now to solve here, right, I have a divide by 15. I'm going to multiply by 15, right? So I'm just left with 1x, which is just x, and I multiply by 15 here, and I get x equals -150, which is a solution to my equation. Okay, so here all I had to do was bring my x terms, my 2/5 x and my 1/3 x, and put them on the same side of the equation. And then I solve it just like as if it had whole numbers. All right, and the second method I'm going to show you allows us to eliminate the fractions. And some people like this because, they don't want to deal with fractions, which is fine. So if this method works for you, great, but there's a couple things we have to be very careful about. So I have the same equation, 2/5 x minus 8. So what I'm going to do is I'm going to use the idea of a least common denominator. to wipe out the fractions. Well, the way that I do that, I see that I have a 5 on the bottom here, right? And that's the only fraction that I have. So I'm going to take everything here and multiply by 5. Multiply the left side by 5 and the right side by 5, which I'm allowed to do because all I'm doing is multiplying on both sides of the equation, right? Just like I can add 2 to both sides, I can multiply both sides by 5. So now I have 5 times 2 divided by 5 gives me 2x. 5 times negative 8 gives me negative 40, right? I have to make sure that I'm not just multiplying out the fraction, but I'm multiplying everything by 5, including the right side here. 5 times 12 is 60. Well, the reason that this technique is nice is now I have a very straightforward equation that has only whole numbers in it, right? So I've wiped out those fractions. So 2x is 100. I divide by 2 and I get the same thing, right? I still get x equals 50. Okay? So the nice thing here is I didn't have to deal with the fractions. I was able to get rid of them right away. On this one, the technique for doing that is a little trickier, right? If I multiply by 5, I'm still going to have a fraction here, right? Because if I do 5 times 1/3, I don't get a whole number. So instead of multiplying by 5, I'm going to multiply by the least common denominator. So if I have 5 and 3, the least common denominator is, think about that for a second. What number can I multiply to get rid of the 5 and the 3? And the answer is, of course, 15. So let's see where I am now. So 15 times 2 is 30, divided by 5 is 6. So I have 6x. I'm going to distribute the 15. 15 times 4 is 60. Okay. And then I have 1/3 times 15. 1/3 x times 15 is 5x. Minus, let's see, 15 times 6 is 90. Okay. So now I've got an equation. I still have variables on both sides, but I don't have any fractions. So now I'm going to take away the 5x from each side. I'm going to get 6x minus 5x. Well, that's just 1x. Let me write that a little bigger. 1x plus 60 equals, be careful, negative 90. And then I subtract 60, and I'm here, right? I have 1x, which is just x, equals negative 150. Okay? So if we think about this, right, you have to decide on the method that's going to work best for you. If you're okay with dealing with fractions, and especially with getting common denominators, you'll be able to just work with the fractions. But if you're somebody who prefers to get rid of the fractions and use a least common denominator right away, you may want to try the second method. So use those to complete the problems that you have in front of you, and hopefully you should be able to be successful with those. Okay, thank you.